Welcome back to All This Math. This is Professor Parker. And for this next lesson, we're going to talk about factoring using a method that I like to call the Malcolm X method. And I'll explain to you why it's called the Malcolm X method. Well, actually, it will reveal itself to you why I call it the Malcolm X method. And this is also why I wore my Malcolm X Liberation University sweatshirt. And let me tell you a little bit about Malcolm X Liberation University before we get started. Malcolm X Liberation University was a independent Black educational institution. It was a college founded and located in Durham, North Carolina, all right, which later relocated to Greensboro, North Carolina. And it was a short-lived institution. I think it only lasted like three to 4 years because of funding issues. And as I said, it wasn't even an HBCU. It was an actual independent Black college, right? It wasn't a land-grant college. It was founded by a collective led by a brother named, and I might be messing up the pronunciation of his name. When he changed his name to a Swahili name, his name was Owasu Sodukai. Today he goes by the name of Howard Fuller. He's an educator. I believe he's in the Minnesota, either Minnesota or Wisconsin area. I want to say Minnesota, but I could be incorrect. You can Google him any time and find out more information about him. But it was an independent Black institution. And I learned about it from reading a book called We Are an African People that chronicles the history of independent Black educational institutions in the United States in the 20th century. And I highly recommend that book because one of the things that book did for me was it kind of let me see that building independent Black educational spaces was a reality and there was a long history of it. I mean, I knew there was a history of it, but to read the book and actually read about the stories and the experiences to see that, this was really a tangible thing, and it can be a tangible thing today, which is part of why I've been motivated to create this YouTube channel, All This Math, and continue to build it and grow it out so it can provide service to the community. So anyway, when we get into the math problem, Malcolm X method, it kind of ties into Kwanzaa and the Nguzo Saba, and the second day of Kwanzaa, which is Kujichagulia, which means self-determination, which means basically our ability to define things for ourselves and by ourselves. And you might be asking yourself, well, why would you call it that? And I say, why not? Why not call it that? We can call the math that we do anything we want to call it. We have that right. We have that ability. Who's going to stop us, right? The terms that we use to describe mathematical processes and topics typically are just the result of other people having self-determination and deciding that they're going to call it that. So what makes any other group of people better than us? We can call it whatever we want, right? As long as we know how to recognize it when we see it in a textbook or we see it in a workbook or we see it in a class somewhere, we know what other groups of people may call it. As long as we know how to recognize what it is, but among ourselves, we can call it whatever we want. And then who knows, if it spreads, then what we call it may become more of a mainstream, descriptor of it. So anyway, factoring, Malcolm X method. Let's get into the nuts and bolts of this problem. We have 18x squared plus 9x minus 5. We want to factor this. So when I say factor, what I'm trying to say is we want to break it down into separate parts. In this case, because we're dealing with a trinomial, which has 3 terms, 1, 2, 3, we want to break this down into 2 binomials by the time we're done. All right. Now, first thing you always want to do is check to see if there's a GCF or greatest common factor that all 3 terms share. This 18x squared and this 9x, they have a common factor, but the GCF must be common to everything. This 5 has no common factor that it shares with the other terms except for 1. And if 1 is your greatest common factor, that don't change nothing. So that ain't going to help you. So you don't even got to worry about that. All right. So now we say, okay, this is a trinomial. It's got 1, 2, 3 terms, and it's quadratic. Biggest exponent is a 2. So I'm going for the Malcolm X method. Now for the Malcolm X method, and I kind of just basically remix something like on the internet, on YouTube, a lot of teachers, they probably call this the diamond method, right? But you end up drawing an X and putting numbers in the different portions of the X or different parts of the X. So I figure like, why not evoke the name of one of our greatest ancestors, Omowale Malcolm X? Why not? All right. So first step though is the lead coefficient, which is 18. The lead coefficient is always attached to the variable with the biggest exponent. All right. usually your expressions are going to be written in what we call descending order, meaning the biggest term with the biggest exponent is first, the term with the next biggest exponent is next, and then the term with the next biggest exponent is last. Now you might say, well, there's no variable there, so how can you say that? Well, we could think of this as 5x to the 0 power, and that x to the 0 power being invisible because x to the 0 power is equivalent to 1 anyway, so we could think of it like that. All right, but anyway, your lead coefficient gets multiplied by your constant at the end of the expression. So first thing we're going to do is this. You're going to do 18 times negative 5. And we should know our multiplication facts to be able to figure out what 18 times 5 is. And that's a negative 5, but we could treat it like it's positive first and then just make our product negative. Because we know at the end of the day, our product is going to be negative, because whenever you multiply positive by a negative, you always end up with a negative product, right? So 18 times 5, I know that that's 90. But the way I do it mentally is I use distributive property. So basically what I do is I take 18 and I break it down into 10 plus 8, right? I kind of break it down. And why do I do 10 plus 8? Because 10 ends in a 0. And if a number ends in 0, it's easy to do multiplication by any other number. So if I want to do 10 times 5, it's going to be 50, right? Because 1 times 5 is 5, so 10 times 5 is going to be 50. And this trick works with all numbers. And then I just got to do the other part, which is 8, because I broke the 18 down into 10 and 8. So 8 times 5 is going to be 40. So I take the 50, add it with the 40, and I get 90. So 18 times 5 is 90. But remember, we're multiplying a positive 18 by a negative 5, so that means actually our product is going to be negative 90. So you write your negative 90 right there, and then you write your coefficient of your middle term or your linear term, which we call it B. You know, I call it B because, well, that's what most textbooks call it, B, because the lead coefficient is your A, the middle term coefficient is your B, and the constant is your C. So B is going to equal positive 9. Now this is when we get to the Malcolm X method, and the reason why I call it that, because you draw X, right? And this product right here, right? This product right here is going to go up in the top section, negative 90. So negative 90 goes up top. The coefficient of the middle term, which is 9, that's going to go down here, right? Now, and again, this is basically, you know, a familiar method, a method that you might be familiar with. You might have seen it on YouTube, or maybe your teacher might have taught you to do it this way already. They probably just called it the diamond method. But I chose to just change the name, you know, and call it the Malcolm X method, right? Now, what numbers are going to go here and here? That's the question. Now, the numbers that go here and here will be factors of this number that also add up to this number. Now, this is where it kind of gets a little fun. At least I think it's fun, because it's like a puzzle. Factors of this number up here that add up to this number. So off the top, I know that it's going to be positive 15 and negative 6. Because positive 15 times negative 6 also equals negative 90, right? Because we got 10 times 6 is 60, 5 times 6 is 30. Put the 60 with the 30, you get 90, right? And also positive 15 plus negative 6 is the same thing as doing 15 minus 6, which gives us 9, right? But let's say I didn't know that. If you don't know that, and a lot of people don't know that, a lot of people don't know the factors of random numbers off the top of their head, and that's fine. I just happen to have a lot of practice. That's why I know it, right? But if you don't know it, what I suggest is you just write out a list of factors of this number, right? Just write out a list of factors. So you start with, I would say, negative 90 and times 1. And then I know negative 45 times 2. And I know negative 30 times 3. And I'm thinking like, does 90 divide by 4 evenly? And I say, no, it doesn't. 90 don't divide by 4. Now, how do I know that? I need to do a separate video on this concept alone. How do I know that 4 don't go into 90 evenly? Well, this is how I know. Because I know that 4 goes into 80 evenly, right? It's kind of like a application of like the partial quotients method, right? So I know 4 goes into 80 evenly, because 4 times 20 is 80. Well, 4 $20 bills is $80, right? So 4 goes into 80 evenly, and then the difference between 90 and 80 is 10. Does 4 go into 10 evenly? It don't. So if 4 did go into 10 evenly, then 4 would have to go into 90 evenly, because 4 goes into 80 evenly, but the leftover, which is 10, 4 don't go into that part evenly. So it can't go into 90, since 90 is the sum of 80 and 10, right? And you could do that with any numbers, you know what I mean? So skip 4. I know 5 is a factor because any number that ends in 0 is divisible by 10 and 5 guaranteed. If it ends in 0, it's divisible by 10 and 5, guaranteed. All right, so how many 5? Well, we already know. We did 18 times -5 to get -90. So I'm going to say -18 and 5. And then 6. Is 6 a factor? Here's another little math trick, and I need to do another video about this too, right? So if I'm saying I want to see if 6 is a factor, 6 is just double of 3. So if 30 times 3 gives me 90, then that means that 15 times 6 must give me 90. Now, how do I know that? Because all you doing, let's say you got 30 groups of 3. That's got to be the same amount, total amount, as 15 groups of 6. Because 3 doubled gives you 6, but at the same time, half of 30 gives you 15. So if you double one and take half of the other, you're going to end up with the same amount. 30 times 3 is 90. But if you double the 3, that gives you 6. But at the same time, you keep it balanced, and you take half of the 30, that gives you 15. So 15 times 6 got to also give you 90, right? Because, again, break 15 down, you got 10 times 5. Well, 10 times 6 is 60. And then the leftover 5 times 6 is 30. 60 plus 30 is 90. All right. So we got -15 and 6. All right. Now what about 7? 7 don't go into 90 because I know that 7 goes into 84 because I know my timetables. And I know 7 times 12 is 84. And the difference between 84 and 90 is 6. And 7 can't go into 6. So 7 ain't a factor. Is 8 a factor? I know 8's not a factor because 2 times 4 is 8. Another math trick that I just used with the 30 and 3 to figure out 15 and 6. 2 times 4 is 8. So I should be able to divide 45 by 4 to get the other factor that I can multiply by 8. Now there is a factor, but it's not a whole number. It's going to be a decimal because 45 ain't divisible by 4. It ain't. All right. So that's 8. What about 9? Of course, 9, because we could say -10 times 9. Now, once you get to this point, notice how the numbers are going up and increasing on the right-hand side and decreasing on the left-hand side. So I can't really decrease no more. I'm gonna start, repeating the same number pairs. All right. So this is all the pairs of factors that will multiply together equal -90, right? So then we just go through the list and we look for the pair that's going to add up to +9. So I know -90 and 1 will not. -45 and 2 will not. -30 and 3 will not. -18 and 5 adds up to -13. No good. -15 and 6 adds up to -9. So actually, I shouldn't have circled this. -15 and 6 adds up to -9. So we got to also know how to add and subtract positive and negative integers, right? But if that ever happens, notice how I got the right number, but just the wrong sign, because I need a +9. But this gives me a -9. Another trick, if this ever happens to you, if you get the right number with the wrong sign, all you got to do is switch the signs of the two factors. So instead of having a -15 and a +6, you just got to have a +15 and a -6. Because it's still going to multiply together and give you a -90, because one is negative and one is positive, right? But when you add them up, now instead of having a -9 as your result, you're going to have a +9 as your result, which is what you want. So whenever you encounter that situation, that's what you got to do. You just switch the signs. All right? And then we don't got to worry about the -10 and the 9 because we know that ain't right. That ain't it. All right? So you put your 15 over here and you put your -6 over here. Now you got 4 numbers to work with, right? And these 2 numbers are really important, right? You're not really going to use this and this no more. You're going to use these 2, all right? Now, what you're going to do is you go back to the original expression that you first started factoring, right? The original expression, and it was a trinomial. Your next step is to stretch it out into a 4-term polynomial. So think about it. You're going to stretch it out. And how are you going to stretch it out? You're going to change this 9x into 15x minus 6x. 15x minus 6x. All right? So you're going to have 18x squared. That don't change. This 9x is going to change, though. This 9x is going to change. What's it going to change into? It's going to change into these 2 like terms. These are going to be the coefficients of 2 of x's, right? 15x and -6x. Matter of fact, if you want to, you can put them right here. So 15x minus 6x, because that's the same thing as 9x. all we doing is we rewriting this expression, except with instead of having just 3 terms like we had when we started, it's going to have 4 terms, right? And the reason that we want to do that is because then we get the factor by grouping. That's going to be the next thing we're going to do. So we're going to have 18x squared plus 15x minus 6x minus 5. So look, notice how the 18x squared ain't changed. The minus 5 didn't change. The only thing that changed was that 9x. So your middle term got to be broken down into 2 separate terms that add up to it. All right. So 15x or subtract together to get to it. So you got 15x and minus 6x. All right. Now we do the factoring by grouping. All right. And we talk a little, and I like to talk a little bit more about Malcolm X when I get to this part because it's relevant. I see like an organic connection, right, between my process. So we want to factor by grouping. So we want to first make 2 groups. Similar to how Omowale Malcolm X did at the end of his life, he created 2 groups. He created 2 organizations, right? And one of the things that Marcus Garvey talked about, one of the things that Kwame Ture years later talked about, is that our people should always be organized. Organize, organize, organize. Be a part of an organization that's working toward the liberation of African people globally, or start an organization that's working toward the liberation of African people globally, right? So we got to create 2 groups. So I like to think of these 2 groups as the Muslim Mosque Incorporated and also the Organization of African American Unity, right? Because that's what brother Malcolm did before his assassination. So we got 18x squared plus 15x, boom, in the parentheses, plus negative 6x minus 5, right? Now, remember in the beginning of the problem, when I was like, does this have a GCF? That's always the first thing you should look for when you ever doing a factoring problem. A problem with factoring algebraic expressions, no matter what kind they are, whether they quadratic, cubic, whatever, right? Now, when you factor by grouping, you create your 2 separate groups and you find the GCF of each group. So the GCF of this group, this binomial right here, is going to be 3x because the GCF of 18 and 15 is 3 and the GCF of x squared and x is just x. So the GCF is going to be 3x. All right, so we got 3x, right? And then we figure out what goes inside the parentheses by doing division. 18x squared divided by 3x is going to be 6x. 15x divided by 3x is going to be 5, right? Then over here, we got negative 6x minus 5. So the GCF of negative 6x minus 5 is just going to be negative 1. We want to factor out a negative 1. Now, you could factor out a positive 1, but what you want to end up happening is you want this binomial and also the binomial that you come up with over here to match up. So that's why another trick with this is whenever you got 2 negatives, or even if you only got 1 negative term, you always want to factor out the negative GCF. So in this case, the negative 1 instead of the positive 1. Because if you factored out the positive 1, you're going to have a 6x, you would have had a negative 6x minus 5, which don't match up with this. So again, another Malcolm X connection. I told you before his assassination, Brother Malcolm started 2 organizations, Muslim Mosque Incorporated and the Organization of African American Unity. Now, what you can say is, you can think of it as, okay, the common factor in both of those organizations was Malcolm X, right? Because he founded both of them, right? And there might have been some overlap in terms of the membership of some other people that I'm just not familiar with right now. But think of 6x plus 5 right here, 6x plus 5 right here, Malcolm X right here, Malcolm X right here. Then to write your final answer, what you do is you take these 2 terms and basically put them together. 3x minus 1 comes together and 6x plus 5 comes together. Now that's a shortcut way to think of it. That's how I learned this years back. But initially I didn't realize that all you doing in this step is you taking the GCF again. We took the GCF of this and got 3x. Took the GCF of this and got negative 1. Now we think of it as that's 1 term and that's another term. The GCF of these 2 is 6x plus 5, right? So we think of it that way. That's my 6x plus 5. The 6x plus 5 is the greatest common factor out of these 2 terms, these 2 long terms, right? And then how do we get 3x minus 1? Because if we do this whole term, or 3x times 6x plus 5 divided by 6x plus 5, what's going to happen to the 6x plus 5s? They're going to cancel out, leaving you with what? The 3x. So you throw the 3x right in there like that, and then you do the same thing. 6x plus 5 was part of the was the GCF. divide -1 times 6x plus 5 divided by 6x plus 5, what's going to happen to the 6x plus 5s? They're going to cancel out again, leaving you with just -1. So where do you put the -1? In the parentheses with the 3x. So this is our final answer. This is our final answer. Like I said, online, on YouTube, wherever you go, you may see this method, and it might be referred to as the diamond method. I don't want to call it the diamond method. I ain't trying to talk about I'm not worried about diamonds. And I think people need to evoke the name of Malcolm X in different contexts, and also early and often as much as possible. So why not be in an algebra class and talk about Malcolm X in a way that's organic and seamless, and also lends itself toward helping students, you all out there, to remember what the steps are. Because now what I've done is I've attached this algebraic algorithm to a story about our history. That's what I've done. And I've been intentional about it. And I've done this with a lot of other mathematical topics and concepts as well. And if you've seen any of my other videos, you heard me mention hystematics, which is something else I've been developing. This ties in right along with that. This is an example of hystematics. Me doing math and wearing a Malcolm X Liberation University sweatshirt and talking about it is hystematics. Me just being a black man teaching math is hystematics, right? So it all ties in. So at any rate, this is the Malcolm X method, otherwise known as the diamond method in some spaces, but I don't really like to call it that. But and that's my prerogative. That's my right. Remember, we talked about Kujichagulia, self-determination, the second day of Kwanzaa. That's what it's about. Definition, defining things for yourself. But use this video as a guide. I know there were a lot of steps that I went through, and this is a lengthy process, and it's a lot to think about. The problems really aren't that long, but I just was trying to be real thorough and real detail-oriented so as to go over everything so you would get a good understanding of what's going on in these problems. But ask your teacher, ask your professor for practice problems on factoring quadratic trinomials. Or if you can't do that, go online and just do a search for factoring quadratic trinomials worksheets. And they'll come up with problems, plenty of problems. Practice using this method, practice using this method. And then, when you're done doing that, go read up some more on Malcolm X or listen to some of his speeches. The Ballad or the Bullet, I highly recommend. You know what I'm saying? And if not that, what's the other one? My other favorite one by Malcolm is Message to the Grassroots, 1963. I believe he dropped that in 1963. Yeah, Message to the Grassroots. So definitely get strong in math, get strong in your history, and I'll catch up with you on the next video. All right? Peace.